Recently, India launched E85 fuel, a high ethanol fuel containing approximately 85% ethanol and 15% petrol. In a previous video, we explained the engineering behind E85, including vehicle compatibility, fuel economy, performance, and the challenges associated with high ethanol fuels. If you would like a detailed explanation of E85 fuel, you can find the video through the link in the description. However, fuel is only one part of the equation. For ethanol-based fuels to be used effectively, vehicle must also be designed to operate with them. This brings us to an important automobile technology known as flex fuel vehicles, often referred to as an FFV. Interestingly, this topic has become especially relevant because Maruti Suzuki has introduced India's first flex fuel passenger vehicle. At first glance, the vehicle looks almost identical to a conventional petrol vehicle. However, underneath the surface, important engineering modifications allow it to operate on a wide range of ethanol-petrol blends. So, what exactly is flex fuel vehicle? How does it work? What modifications are required? And why are manufacturers beginning to invest in this technology? In this video, we will explain the engineering behind flex fuel vehicles, analyze Maruti Suzuki's newly introduced flex fuel vehicle, and discuss the practical challenges facing this technology in India. What is a flex fuel vehicle? To understand a flex fuel vehicle, we first need to understand its purpose. A conventional petrol vehicle is designed around a specific fuel type. Engine calibration, fuel delivery, ignition timing, and numerous other parameters are optimized based on the expected fuel characteristics. A flex fuel vehicle is different. Instead of operating on a single fuel type, it is designed to operate on the multiple fuel blends containing varying amount of petrol and ethanol. Depending on the vehicle design, this may include regular petrol, E20, E85, or various mixtures between them. The key advantage is flexibility. The driver does not need to manually configure the vehicle when switching between them. The vehicle automatically adapts itself according to the fuel composition present inside the tank. This ability to operate on different fuel blends is what gives flex fuel vehicles their name. How does a flex fuel vehicle works? At first glance, the concept may sound simple. However, the engineering behind it is surprisingly sophisticated. The most important component is the fuel composition sensing system. This sensor continuously monitors the ethanol content of the fuel flowing through the system. The information is then transmitted to the engine control unit, commonly known as the ECU. The ECU acts as the vehicle's central control system. Based on the detected ethanol percentage, it adjusts fuel injection, ignition timing, air-fuel ratio, cold start strategies, and various other operating parameters. These adjustments are necessary because ethanol behaves differently from petrol. As fuel composition changes, the engine must continuously adapt to maintain proper combustion and reliable operation. All of this happens automatically. In most situations, the driver may not even realize the system is making adjustments. This seamless adaptation is one of the most important engineering characteristics of flex fuel vehicle. So, why flex fuel vehicles require special engineering? At this point, an important question emerges. If flex fuel vehicles can use high ethanol fuels, what makes them different from ordinary petrol vehicles? The answer involves both software and hardware. Ethanol has different chemical and physical properties compared with petrol. As ethanol concentration increases, fuel delivery requirements also change. The engine generally requires a greater amount of fuel to produce the same amount of power. Because of this, fuel injectors, fuel pumps, engine calibration system, and fuel management strategies must be capable of operating under these conditions. Material compatibility is another important consideration. Fuel lines, seals, gaskets, and other fuel system components must be designed for long-term exposure to ethanol-rich fuels. Without these modifications, durability and reliability could become concerns over extended period of operation. This is why flex fuel vehicles are engineered specially for high ethanol applications, rather than simply being conventional petrol vehicle filled with a different fuel. One of ethanol's most significant characteristics is its high octane rating. Compared with conventional petrol, ethanol offers greater resistance to engine knock. Engine knock occurs when combustion happens at an undesirable time inside the engine, reducing efficiency and increasing stress on engine components. Because ethanol resists knock more effectively, manufacturers can potentially use more aggressive ignition timing and higher compression ratios. Under the right condition, this can be improved engine performance. However, fuel economy tells a different story. Ethanol may offer certain performance advantages. It contains less energy per liter than petrol. As a result, the engine generally requires more fuel to produce the same amount of power. This often leads to increased fuel consumption compared with conventional petrol operation. The overall operating cost depends on fuel price, fuel economy, vehicle design, and driving conditions. This is one reason why real-world testing remains important when evaluating any new fuel technology. Now let's talk about Maruti Suzuki's Flex Fuel WagonR. Now that we understand the engineering behind flex fuel vehicles, let's see Maruti Suzuki's newly introduced Flex Fuel WagonR. This vehicle represents an important milestone for Indian automotive industry. For many years, flex fuel technology was discussed primarily through concepts, demonstrations, and pilot projects. The WagonR changes that. It represents one of the first major attempts to introduce flex fuel passenger vehicle technology into the mainstream market. To achieve this, Maruti implemented both hardware and software modifications. The vehicle fuel system has been adapted to support ethanol-rich fuels. The engine management system has been calibrated to operate across different fuel blends. Special sensing system allows ECU to identify fuel composition and adjust the operating parameter accordingly. While these modifications may not be immediately visible for normal customer, they are essential for reliable operation under varying fuel conditions. More importantly, the launch demonstrates that manufacturers are beginning to prepare for a future in which multiple fuel technologies may coexist within the market. The Maruti Suzuki is unlikely to remain the only manufacturers exploring this technology. Several companies have already demonstrated ethanol-compatible vehicles and flex fuel concepts. Motorcycle manufacturers have also begun introducing flex fuel models. At the same time, fuel suppliers are gradually expanding ethanol infrastructure. However, large-scale adoption depends on several factors: vehicle availability, fuel availability, consumer confidence, long-term reliability, and overall operating economics. All of these elements must develop together for flex fuel technology to achieve widespread adoption. Thanks for watching. If you found this analysis helpful, consider subscribing for more content related to automobile engineering and technology.